These are the Lesson 9 3 notes for Day 2. Again, we're talking about rational functions, and again, we're going to be locating asymptotes and intercepts on rational functions. Just a reminder, when we're graphing equations like this on your calculator, we're going to make sure that our stat plots are off by going to second y equals and making sure all of these say off. In our equation for y equals, it does say 2x plus 3 in the numerator. In the denominator, there are two different factors. So, because of this, we're going to put parentheses around this entire denominator, even though they don't originally appear in the problem. When you type this in your calculator, it's necessary to do this. Otherwise, you won't end up with the correct graph. So we're going to get this x minus 1 times x plus 4 in here with a double set of parentheses. We will graph this in just a moment. For my window, I'm going to use my standard viewing window. Easiest way to get there is to do zoom 6. This will give us our standard viewing window. Some calculators, you may see something that looks like this. Other calculators, what you won't see are sort of these vertical blips right here. And that's fine. You still should see kind of a curve right here, curve right there, and we've got another curve up here in the upper right corner. You may recall from a few days ago that the asymptotes of this graph appear to be sort of where these blurps appear on my graph. They appear to be around -4 and +1. And that's true because at +1 and -4, you'll notice in our problem, +1 would cause our denominator to equal 0. You can't divide by 0, which means that there is no value on our graph at 1. There's instead an asymptote, which we'll denote by a vertical line. Same thing is true at -4. I'm going to do 1, 2, 3, 4 tick marks, and we'll do a vertical line here at -4 to denote that that's an asymptote as well. I'm going to write this as an equation, x equals 1, comma, x equals -4. Those are our vertical asymptotes. For our x-intercepts, it appears that there's an x-intercept around here. Kind of looks like around -1 maybe. To find x-intercepts, you may recall, they are values which cause our numerator to equal 0. So values that cause our denominator to equal 0 are the vertical asymptotes. Values that cause our numerator to equal 0 are x-intercepts. So to figure out what would cause this to equal 0, what we can actually do is we can write 2x plus 3 equals 0. We can solve this equation for x to figure out what x would equal for this little expression here to equal 0. Subtract 3 from each side, you're going to get a -3 on the left side of this. So we have 2x equals -3. And to solve this, divide both sides by 2, and you get x equals -3 halves, which is about -1.5. So we'll put a little dot here at -1.5. That's my x-intercept. If you want to write x equals -1.5, you can do that, or you can write -1.5 comma 0. To find the y-intercept of this equation, what we do is we plug in 0 for every x in this equation. So what we're going to do is we're going to do 2 times 0 plus 3. That's just equal to 3. In our denominator, we're going to do 0 minus 1, which is -1, times 0 plus 4, which is 4. If you do 3 over -1 times 4, that's -3/4, which is -0.75. And it's pretty clear on our graph that it looks like it crosses the y-axis below the x-axis. So we'll put a little tick mark, or a little dot, excuse me, at -0.75. The last thing we have is our horizontal asymptote. It appears that this graph, as you move further and further to the left and further and further to the right, has a horizontal asymptote of the x-axis. That is true. You can also say this is the line y equals 0. So I'm doing some little dashes along my x-axis here. So you can see we have a curve in the bottom left corner that does something like this. We have a curve that starts in the upper, kind of right past this asymptote, and it starts up high along this asymptote, crosses our x-axis at -1.5, crosses the y-axis at -0.75, and veers down like this. Across the asymptote, it picks up here again, and then we'll kind of veer off this way. And that's our graph for our first function. For our second function right here, what I'd like you to do in just a moment is pause the video, see if you can find the locations of the vertical asymptotes, x-intercepts, and y-intercept. You can use your calculator to help you out, but it will involve values that are in this equation. Wait on the horizontal asymptote. We'll talk about this in a moment. The hint is it's not the x-axis this time. But pause the video, see if you can come up with vertical asymptotes, x-intercept, and y-intercept, and we'll see what you came up with. So for our second function, we have two vertical asymptotes, x equals 0 and x equals 3. These are the vertical asymptotes because if you plug in 0 for this x, obviously you get 0. And if you plug in 3 for this x, you would also get a 0 in the denominator as well. So these are our two vertical asymptotes. There are two x-intercepts as well. If you plug in -1 for x in this numerator here, you would get 0 for this factor. So that's one value that would cause us to get 0 in the numerator. The other value obviously is 5, because if you plug in 5 here, you would get 0 as well. This graph happens to have no y-intercepts because if you plug in 0 for each x, what you get in the numerator is 2 times 1 times -5, which is -10. But in the denominator, you get 0 times -3, which is 0. Since you can't divide anything by 0, there's actually no solution. You can write this with an empty set notation. So let's graph what we have so far. We have our vertical asymptotes at x equals 0, dashed line along our y-axis, which is the line x equals 0, dashed line at x equals 3 as well. That's our other vertical asymptote. X-intercepts at x equals -1 and x equals 5. No y-intercepts. Now you'll notice by the graph, we appear to have this asymptote, but it's not on the x-axis. If you count tick marks, it appears to be about 2 tick marks up. And it actually is along this line y equals 2. That's actually your horizontal asymptote in this problem. It's not the y-axis. You can see as you move far to the right and far to the left, the graph doesn't get closer to the x-axis. It gets closer to this line y equals 2. So what we actually have for our graphs is we have a graph that does something sort of like this. We have a branch up here that kind of does a little U-shape. And then we have a branch down here that crosses the x-axis at 5 and then goes along this horizontal asymptote. So again, on this third problem in the bottom left of our paper here, x plus 4 times x minus 1 times x minus 3, what I'd like you to do in just a moment is pause the video, see if you can find the locations for the vertical asymptotes, x-intercepts, and y-intercept. This time we'll have something completely different for the horizontal asymptote as well. So pause the video and see if you can find those three things. So again, to find our vertical asymptotes, what we do is we look for values that would cause our denominator to equal 0. There's one vertical asymptote in this problem. It's x equals 3. So we're going to go 3 tick marks over and do our vertical line right here. On older calculators, you'll see a vertical line here. On newer calculators, you won't see anything here. For our x-intercepts, there are two values that cause our numerator to equal 0. Those would be -4 and +1. So our graph has 2 of these x-intercepts. We'll plot those right here at -4 and 1. There's one y-intercept. It's located at 4/3, which is about 1.3 repeating. So we'll pull a point here. Now you can see pretty clearly on the left side of our graph that our graph kind of goes at a diagonal this time before veering down through our intercepts and going this way. There's nothing that appears on the right side of our graph, which is kind of curious. And what you actually have to do is we have to bump up our window to see a little bit higher up our graph. I'm going to see a y max of 20. And by doing that, you can see that we now have something that appears up here. What it actually is it's a continuation. If you were to imagine that our graph continued this line right here, it kind of looks like a line right here. That's basically the angle that this graph is going to continue at, except that we do have this asymptote up here that the graph follows right like this. This graph has no horizontal asymptote. What it actually has is it has an oblique asymptote, a diagonal line asymptote. More on that later. What I'd like you to do next is I'd like you to attempt to see if you can find the vertical asymptotes, x-intercepts, and y-intercepts. Maybe you can figure out the horizontal asymptote too. See if you can put it all together, identify these parts, graph it. We'll pause the video, and we'll see what you get in just a moment. So for this graph, we have two vertical asymptotes. One's located at 4. The other is located at 1/2. Where the 1/2 comes from is if you actually set this little expression here, 2x minus 1 equal to 0, and solve for x, you would get 1/2. So I'm going to do my tick marks here, 1, 2, 3, 4. Do my vertical asymptote here at x equals 4. And then we have another vertical asymptote here at x equals 1/2. Secondly, we have our x-intercepts. There's 2 here, x equals 0, x equals -1. These are pretty close to each other. So we'll put these dots here and here. The y-intercept is equal to 0 because if you plug in 0 for each x into this equation, you'll get 0 times 1 equals -4 times -1. This is equal to 0 over 4, which equals 0. So the y-intercept is actually the same location as the x-intercept. What's a little bit tougher to see here are the horizontal asymptotes. You can see that this graph is leveling off, again, not along the x-axis. So what's kind of helpful to do here is if you actually extend out your x-min to -20 and your x-max to +20, you can see a little bit easier where this graph levels off. It appears to level off at about 3 units up. So we're going to go 3 units up on our y-axis and draw a vertical line at y equals 3. Now, what's hard to see now is the detail that's going on around these two x-intercepts. So to see this a little bit better, I'm going to shrink my window in. In fact, I'm going to go from -5 to +5 for my x-min and x-max. And some calculators, again, will show these blips and others won't. You can see our graph kind of comes in. Looks like it crosses at -1, but then comes back at 0 and goes up. Then we have a little kind of a downward thing over here, and then we'll come back, expand our window to see what's going on the right side. So over here on the left side, our graph is right around this asymptote, but that's going to come down through this intercept and then back up through this intercept. It's actually going to cross our asymptote here, which we know is okay. And then down here, we have kind of our little curve that does something like this. Now again, if we extend our window out to +10, you can see what's going on the right side of this graph, which is our asymptote like here, and the curve going along this asymptote here. And this is what our graph looks like. Now if you're wondering, how do you know where these asymptotes are at, other than kind of estimating by the graph? Here's how we know. Our first graph had a horizontal asymptote that was the x-axis. And the reason that the x-axis was the asymptote was because if you were to actually multiply out the numerator and denominator, we have a total of 1x up at the top. The degree of the numerator is 1. In the denominator, we have 2 x's. We say the degree is 2. And if there are fewer x's on the top compared to the bottom, so if the numerator has a smaller degree than the denominator, it's always the case that the horizontal asymptote will be the x-axis. So we know this, that y equals 0 is the horizontal asymptote if the numerator has a smaller degree than the denominator. In the second and fourth problems that we looked at, we had horizontal asymptotes that were not along the x-axis. This one had a horizontal asymptote of y equals 2. In the bottom, we had a horizontal asymptote of y equals 3. Where does this come from? Well, if you were to actually take the number of x's on the top and bottom of this fraction, you'll notice that there are 2 x's on the top and 2 x's on the bottom. The degrees are the same. There's the same number of x's on the top and bottom. And the same thing is true in the fourth problem. There were 2 x's on the top, 2 x's on the bottom. If the degree is the same, then what we do is this. If you were to imagine multiplying out the numerator, what you would end up with is a 2 times an x times another x, which is like 2x squared. On the bottom, we have an x times x, which is x squared. And if you're thinking, what's 2x squared over x squared equal to? Well, the x squareds cancel out, and you're just left with 2. That happens to be your horizontal asymptote. On the problem on the bottom, if you multiplied the 6x times the x, you would get 6x squared. On the bottom, if you were to multiply x times 2x, you would get 2x squared. Again, sort of like the x's cancel. In this case, the x squareds cancel, and you have 6 over 2, which equals 3. That's where your horizontal asymptote comes from. So if the numerator degree is equal to the denominator degree, you multiply a divided by b, where a is the lead coefficient of the numerator and b is the lead coefficient of the denominator. Now there's no horizontal asymptote in the third problem, and that's because there are 2 x's in the numerator and 1 in the denominator. If the numerator has more x's than the denominator, then there is no horizontal asymptote. So we say if the numerator degree is bigger than the denominator degree, then there is no horizontal asymptote. And now you should be able to take a rational function and figure out vertical and horizontal asymptotes, as well as x and y intercepts.